starting to take a look at some calculus functions using the Sims operations in MATLAB. We have limits that we're going to start with. And this is a pretty easy section because limits are just taking the limits of functions. And if you have a function f as x approaches the value a, you can use this command right here, limit f comma x comma a, and that finds the limit as the function f as x approaches a. You might remember from Calculus 1 that there's left-hand and right-hand limits. And so if you want to just find a left-hand limit, you just put in a fourth parameter and in parentheses or in quotation marks left. And if you want to find the right-hand limit, you just do quotation marks right. Right? Now, let's go through and do a fairly easy sort of function or sort of operation from Calc 1 is we want to determine what the limit of a function is. So the user is going to enter a function in terms of x and then a value a. If it exists, the program will find the limit. If it does not exist, then it won't find the limit and it'll say that there is no limit and it'll state why. And you might recall from Calculus 1 that the way to determine if a limit does not exist is, and I'm just going to draw a really basic example here. So now, excuse me, I'm using my mouse here. But let's say the function does something like this as it approaches 0, and that's from the left side, and then from the right side, it does something like this. And so notice that the function is reaching two different values from the left and the right hand side. And so if the values are different, then remember we say that the limit does not exist. Okay, and again, excuse my terrible mouse writing. Okay. All right. And of course, if the limit does exist, like for instance, if we have a quadratic and it does something like this, and we're looking at the vertex right here, all right, that would mean that the limit does exist because it reaches the same value from the left and the right hand side. All right, so just a reminder of Calc 1. So we're probably going to need an if statement once we find the left hand and the right hand limits. So let's get to it. All right, so two things we need. So we're going to get a symbolic variable first. So we're going to say sims x, and we're going to ask the user for the function. All right, so we're going to input, and we're going to say enter a function in terms of x. And then we're going to get a value for a. And I'm just going to call that a, input. And we're going to say enter the value a. All right, so now we have x and a. And now we're going to find the left hand and right hand limits. So I'm going to say left is going to be equal to limit of fun, comma, as x approaches a from the left. Okay. And surprisingly, let's do the same thing for right. All right. And so now we're going to have an if statement. Okay, so we're going to say if left equals right, and remember we need double equals because it's not assignment, it's checking. Then we're going to f print f that the limit is, and let's just say percent f or percent f. Yeah, we'll do that. And then we'll say backslash n, and I know I spelled the word the wrong. And it really doesn't matter if we use left or right, because remember, they're both going to be the same. All right, if left and right are going to be approaching the same value, then it doesn't matter. Now we're going to say else, if they don't equal, then we're going to f print f. Limit does not exist. And here's the reason. We're going to f print f that left hand limit is percent f and right hand limit is percent f. All right, and then we're going to do backslash n, and let's just say left, comma, right. All right, so that should do it. And we'll do an end. So let's go ahead and run it, and I'll enter a function that I know the limit exists. And hopefully all the syntax is correct. All right, so let's do something like this. Let's say x squared minus 1 divided by x minus 1. All right, and we know we can factor that, and it'll simplify into x plus 1. And we know, so the limit should be 2 as a approaches 1. All right, and so the limit is 2. All right, so that's good. It worked out really nicely. Now, a function that doesn't have a limit as x approaches 0 is the absolute value of x over x. Right? And that's actually similar to the diagram that I tried to draw earlier. So we have abs x over x and 0. And the limit does not exist because the left-hand limit is -1 and the right-hand limit is +1. Right? And this is the exact process that you guys went through, hopefully in Calc 1, where you just either graph the function or use the table of values, and you saw that the limits that were not the same from the left and right-hand limit. All right, so that's how you're going to do limits in MATLAB. They're pretty easy. They're straightforward. Another operation that we're going to start taking a look at is the idea of the derivative. Right? So derivatives, again, are pretty easy in MATLAB. This function, if we have f as our function, and x is the variable for which the function is defined in, it finds the first derivative of f with respect to x. And of course, if we want to find higher derivatives, we just throw in another parameter, which we're going to call n, and that's going to find the nth derivative of the function x with respect to x. So sorry about that. That was a copy and paste error. So one of the most common things that we do in calculus is we find the equation of a tangent line. And of course, the tangent line can be used for a local linear approximation. It finds the slope at a specific point, all kinds of good stuff. All right. So let's just go back to Calc 1, and we're going to write MATLAB code to enter a function in terms of x, surprise, and we're going to prompt the user to enter a value for x. All right. Program's going to find the equation of the tangent line at that point, and then what it's also going to do is it's going to print the slope and print at the given point, and then the equation of the tangent line. And then finally, it's going to plot the function and the tangent line. So it sounds like a lot of stuff going on there. It's actually going to be a really short code for this. And just to kind of remind you guys a little bit about tangent line, the equation that we're going to be using is going to be, remember this equation, y minus y1 is going to be equal to mx minus x1, right? And we could actually solve this for y and get the equation of the tangent line. So we're going to use that solve function, and m is just going to be f prime at x, right? So remember from Calc 1, that's just our derivative at the point. All right, so it shouldn't be too difficult for us to do this. All right, so let's start by, first of all, just getting the stuff from the user. All right, so we're going to do a sims of x, and let's just do a sims of y as well, because we're probably going to have to manipulate and solve for y as well. And so we're going to get the function from the user. So we're going to say fun, not that we haven't seen this before, is going to be input, and we're going to say enter a function in terms of x. A function in terms of x. And then we're going to find our value to find the slope at. And I'm going to call that x1. Because remember, we have our y minus y1 is equal to mx minus x1. And x1 is going to be input, and we're going to say enter a value to find the slope at. All right, so now we've got our function, we got our x1. Now we need to find y1. And y1 is going to be by using that subs function. All right, so remember in the first video we had subs. So y1, we're going to substitute into function the old, and you can see right here, we have substitute the function, the old variable, which was x, the new variable is going to be x1. Right? So now y1 has the value of the function at this point, at the height at this point. Right? We're going to find the derivative. So I'm going to call that derivative, and that's our diff function. So we're going to differentiate fun with respect to x, first derivative, and we're going to find the slope. Well, to find the slope, we're going to substitute back into deriv. So we're going to say deriv. The old variable was x. The new variable is going to be x1. So we're just finding the slope at the point x1. Great. Now, let's go ahead and start finding the equation of the tangent line. Right? So I'm going to call that tan line. And tan line is going to be equal to solve. Or actually, yeah, we can solve. Or actually, let's just create an equation first. So let's call this EQU. And EQ is going to be equal to y minus y1 double equals m, which is our slope, times x minus x1. All right. And now we're going to solve. So let's call this tan line now. Okay. That should be easier. So tan line is going to be equal to solve. And we're going to solve the equation that we just had. And we're going to solve it for y. All right. Now, I'm going to go ahead and run this. And I'm going to use a really easy example to do this with. Okay. So I'm going to run this. And let's just do x squared. All right. So we know the derivative of x squared is 2x. All right. And at the point 1, we know that the slope is going to be 2. All right. And so right here, we have our tan line, 2x. And that makes sense because the slope should be 2 minus 1. And that should make sense as well because we should have 2 quantity x minus 1, which gives us 2x minus 2. And then we just add the 1 from the other side from the tan line. So yeah, this works out nicely. All right, so now we have it. Okay, so now we can go ahead and start printing out all the stuff that we need. Okay, so remember things that we need. So first of all, we need to know what the slope is. So we're going to say the slope at x equals percent f is percent f. In fact, we could just use percent s. And we need x1 and slope. Okay, so the slope at whatever x was, right? And we're going to say the equation of the tangent line. Right? So we can say the equation of the tangent line at x equals percent s is percent s, and now we're just going to change this to tan line. All right, so that's cool. All right. Now let's see, what else were we supposed to do? So program will find the equation of tan, print the slope, print the given point, and print the equation of tan line, done. And then we have to plot the function and the tangent line on the same graph. Okay, so we are going to, let's just do easy plot. And we're going to plot function on the graph. Remember, you have to do a hold. And we're going to easy plot and tan line this time. And we're going to hold off. Right, so let's go ahead and run it. And let's just do x squared. Again, nice and easy one. And we'll do it at 1. All right, so it looks like everything happened okay. I wonder, it looks like a long on trailing backslash. I wonder if maybe a syntax error somewhere. So, but the good news is everything worked okay. Oh, right here, I see it. Somehow I put a backslash. I didn't do backslash n. Okay, got it. So let's run it one more time. So and not sure why it's doing this with the square right here. So maybe I should make that %f because it's not a string. One of the joys of computer programming, figuring out what works and what doesn't work. All right, let's run it one more time. There we go. All right. And we have our graph. It's hiding behind here somewhere. All right, come on out. There we go. So that's pretty cool. And of course, if you're an educator or something like that, you could use this to be able to show somebody, you know, what happens at the tangent line. By the way, if you wanted to plot some points on here specifically, you could just go ahead and you could also back up here. You could do another hold on, and you could do plot x1 comma y1, which is the point, well, x1 y1, and then you could go ahead and do a circle, and then go ahead and run it. And right here, what it'll do is it'll actually put a point on the graph for where the tangent line actually occurs, right? And of course, you could do more than one point if you chose to, all right? So this is actually a pretty cool way for you to be able to plot a few points on the graph to kind of show what's going on specifically at the tangent line if you really wanted to highlight it, all right? So really cool examples of limits and derivatives. And of course, we're going to move on and we're going to take a look next at derivatives, integrals, and then a little bit with power series as well.